Tak ada.
Belum lagi. Lambat. Pagi-pagi lain pun lambat. Dia pun baru bangun.
Ramna sudah mau hujan noh. Lain lambat.
Nak hujan lah.
Sudah mau ayo tengok hitam-hitam punya.
Lah. Seronok tidur ni. Okay, dah nampak kan?
Ya.
Okay. First kita akan bincang exercise on Friday. Okay, so ni teacher guna yang Jashan punya file. Okay, we use Jashan punya buku. Jashan punya latihan. 6.1. Semua orang semak buku masing-masing. Okay. Dia nak masuk ni kejap. Dia kena accept dulu. Apa? Jadi. Okay, question number 1. Ada seorang lagi. Ni semua baru bangun ni. Mana? Yongkin. Seorang lagi. Ni 10 minit tunggu you masuk kelas je. Dah masuk ke? Mana dia? Dah hilang nama. Dia dah. Okay, what is meant by the process of electrolysis? So tolong semak jawapan masing-masing. The process of decomposition of a compound in a molten or aqueous state into its constituent elements when an electric current flows through it. Okay. Boleh dapat salin tanda betul? Kalau salah buat pembetulan. Okay, question number 2, complete the spaces about the electrolytic cell and the process of electrolysis. A, emitter. B, anode. C, anion. D, rheostat. E, cathode. F, cation. G, electrolyte. Okay. H, non-electrolyte is the substance that cannot conduct electric current. Okay, dapat? Number 3, tick right in the boxes to determine the correct movement of ions during electrolysis. Okay, the answer, moving to the anode is the anion. Okay, moving to the cathode is the cation. Here, bawah ni jawapan dia. Okay, please do correction, Jashan. Okay, yang lain pun tolong take note, do correction. Okay, boleh follow? Next, page 76. Okay, 6.2. Number 1, ionic compounds undergo electrolysis in molten and aqueous state. Ionic compounds do not undergo electrolysis in solid state. Manipulated variable state of ionic compound, namely solid, molten or aqueous. Responding condition of light bulb. Constant type of electrode. Okay. Next. Okay. Observation. Solid led to bromide, not light up. Inference, kita boleh tulis electricity not conductor ataupun kita boleh tulis electric current. Lagi pendek you boleh tulis macam ni. Electric current does not flow. Okay, jawapan pendek you boleh tulis ni Electric current does not flow. Inference. Okay, light up. So kalau light up means electric current flows. Okay, jawapan pendek you boleh tulis macam ni. Electric current flows. Okay. Copper to sulfate solution also light up because electric current flows. Okay, ni jawapan yang lebih pendek lah. Okay, tapi jawapan ni pun betul. Okay. Next. Why does electrolysis occur in molten and aqueous of ionic compounds? Okay, because ions are free to move to conduct electricity. Bukan ini. Okay, dia tanya kenapa boleh berlaku. So the answer because ions are free to move to conduct electricity. Question number 2. Why does electrolysis not occur in solid ionic compounds? Because there are no free moving ions to conduct the electricity. Okay, are the hypothesis accepted? Yes. Okay, conclusion. Ionic compounds undergo electrolysis in molten, aqueous state. Ionic compounds do not undergo electrolysis in solid state. Okay, before we continue, do you know what is the difference between molten and aqueous state? You tahu tak apa beza antara molten dan aqueous? Class?
Don't know.
Tak tahu Okay, molten ni maksudnya kalau you ada contohnya you ada gula. Okay, you ada gula kan? You panaskan gula sampai dia mencair. So gula yang cair tu kita panggil molten glucose lah. Tu maksudnya dia dalam keadaan yang mencair tanpa tambah apa-apa. Kita tak tambah apa-apa, kita just heat it up. Kita cuma panaskan dia. Bahan yang bila you panaskan dia boleh cair, kita panggil molten. Bila dalam keadaan cair kita panggil molten. Molten glucose. Molten sodium chlorate. Like that lah, molten copper macam tu. Okay, beza dengan aqueous adalah aqueous you tambah air. Contoh you ada gula, you tambah air, you panaskan. Okay, that is aqueous. Sebab aqua. Okay, nampak perkataan aqua tu. So means that dia ada air. Okay, molten tak ada air. Dia direct, dia panas, dia cair. Okay, understand? Boleh? Boleh faham? Boleh tak? Faham ni?
Boleh.
Okay, so contoh macam ni macam ni. Molten lead to bromide ni molten. Okay, dia maksudnya you tak tambah air, tak tambah apa-apa, dia mencair. Okay, copper to sulfate solution ni, dia you tambah air. You tambah air, baru dia jadi cair. Lepas tu kita panaskan. Macam tu. Okay, so ni beza lah. Okay, so dia nama macam sama, sifat dia sama tapi dia berbeza. Okay, next. Page 77. Okay, tick right the factors affecting the products of electrolysis. Number 1, type of electrode, position of ions and concentration. Okay, correct. Okay, number 2, electrochemical series. Okay, ion magnesium, ion aluminium, ion zinc, ion hydrogen. Ion kita tak ada ion copper saja, dia ion copper 2. Okay, ion copper 2. Ion silver. Okay, kalau yang tak ada perkataan ion ni, betul dah jawapan ni. Kalium, natrium, kalsium, magnesium, aluminium, zinc, ferrum, plumber masih salah lah. Hydrogen, copper, silver. Tapi bila ada perkataan ion, so copper akan jadi copper 2. Okay, next for anion. Okay, fluoride, sulfate, nitrate, chloride, bromide, iodine, hydroxide. Okay, do correction. Next, B. Okay, circle the ions chosen to be discharged at anode and cathode. State products of electrolysis, then give reason. Okay, anode, hydroxide ion is chosen. The product, oxygen gas. Cathode, hydrogen ion. The product, hydrogen gas. Okay, reason because at anode, hydroxide is located below sulfate ion in the electrochemical series. So the below one will be chosen first. Cathode also same. Okay, hydrogen is located below sodium ion in the electrochemical series. That's why hydrogen is selected. Okay, next. Okay, this is the factor of concentration. Okay, yang ni mungkin Jashan tak perasan. Soalan dia factor of concentration. Kalau factor of concentration dekat anode tu dia berbeza. Mana siapa nak masuk tadi dengan suara, dengan bunyi. Okay, Wendy. Okay dah. Kita masuk ke Wendy. Okay, next sambung. Okay, so at an ion, at the anode, okay, at the anode, ion chosen to be discharged is chloride, not hydroxide. Okay, chloride ion. So the product will be chlorine, bukan gas, chlorine. Will be chlorine. Okay. Okay, so at the cation, copper to iron. Product will be copper. Sekejap, set dulu. Apa nak masuk? Okay, next. Okay, so reason why chloride is chosen. Okay, because chloride ion is more concentrated than hydroxide ion. Okay, so what you see that this dekat dalam gambar ni dia tulis concentrated copper to chloride solution. So bila dia kata concentrated copper to chloride solution, mean in this solution copper and chloride is concentrated than another one. Berbanding yang satu lagi lah hydroxide dengan hydrogen. Okay, however for the concentration dia hanya takes place at anode saja. Kita hanya pertimbangkan di anode saja. Cathode dia masih ikut electrochemical series. Okay, so at the cathode copper 2 is located below hydrogen ion, so copper 2 will be selected. Kalau anda kata hydrogen lebih pekat pun untuk cathode tetap pilih mana yang berada di bawah. Okay, understand? For concentration dia hanya take place at the anode. Hanya anode saja yang kita tengok which one is more concentrated. Okay. Okay, number 4, the factor of the types of electrodes. Okay, so based on the factor of the type of electrode, state the observation and product of at the anode and cathode. Okay, this is copper to sulfate. Okay, based on the factors of electrode. Ni you tak belajar lagi sebenarnya, tapi you tak belajar lagi kan topik ni kan? Betul tak? Yushan, yang lain. Hari ni patut baru belajar ini, betul tak? Tapi tengok dah jawab. Yes or no? Kelas? Kelas? Dah belajar ke belum yang tu? Belum kan? Hari ni baru nak sentuh types of electrode, right? So kita tak jawab lagi lah yang tu. Belum kan? Ya ke dah? Kelas?
Belum.
Belum kan? Okay, so kita tengok next latihan. Yang tu kita tak belajar lagi. So hari ni baru kita bincangkan. Sekejap mana kelas. Okay, so kita tengok next latihan. Kita ambil Alo Zanhao punya. Okay, latihan hari tu tanah Lo Yongqing. Betul semua. Yang lain tak ada yang betul semua Okay, so kita tengok yang Monday punya tugasan. Ini sama je ke lain? Okay, position in the ni dah sama Okay, position of ions in electrochemical series. So kita tengok for position of ions in electrochemical series. The lower the position of the ions in the electrochemical series, the easier the ions are discharged. Okay, what is manipulated? Position of ions in the electrochemical series, responding product at electrode, constant concentration of electrolytes and types of electrodes. Okay. Next. Okay, observation. What you can see at the anode, colorless gas release. Okay, so what is the gas test? Bukan light up glowing splinter ni ni jawapan light up glowing splinter ni you kena letak dekat gas test. Okay, colorless gas release dekat sini saja, observation. Answer for the test gas, light up glowing test kat sini. Okay, so inference, oxygen gas is released. Okay, cathode also same, colorless gas release. Okay, apa ni? A pop sound. You can hear a pop sound with burning splinter, letak dekat sini, gas test. Okay. So inference, hydrogen gas is released. Ni teacher gariskan, means jawapan bawah ni dekat sebelah. Okay. Then how? Okay, next. Write all the formula of ions found in sodium sulfate solution. Okay, dia start dari sini. Sodium ions, sulfate ions, hydrogen ions and hydroxide ions. Okay, write the anions and cations found in copper 2 sulfate solution in the table. Okay, so the anion is sulfate ion and hydroxide ion. Cation, sodium ion and hydrogen ion. Okay, write the formula of ions attracted to the anode Okay, sulfate ion and hydroxide ion. Cathode, sodium ion and hydrogen ion. Okay, write the formula of ion that is chosen to be discharged at the anode. Hydroxide ion. Cathode, hydrogen ion. Explain why. Okay, anode because hydroxide ion selected because it is less electronegative compared to the sulfate ion, atau you boleh kata because it is below the sulfate ion in the electrochemical series. Jawapan lain lah you boleh bagi tahu sebab dia berada di bawah sulfate in the electrochemical series. Okay, B. Okay, the answer is hydrogen ions are chosen because it is located below sodium ions in the electrochemical series. Okay, jawapan yang macam ni lebih tepat. Okay, then how? Okay, are the hypotheses accepted? Yes. Okay, what is the conclusion? The lower the position of the ions in the electrochemical series, the easier, ni apa benda you tulis ni salah the easier the ions are discharged. Okay, that is the answer. Okay, tolong semak jawapan masing-masing. Okay, next. Okay, 6.5, the concentration of electrolyte in electrolyte. Okay, so hypothesis, ions with a higher concentration will be chosen to be discharged at anode. Nampak? Anode je. Okay, manipulated concentration of ion in electrolyte. Response, product at anode. Type, kept constant, type of electrode. Okay, next. Okay, at the anode, what are the observations? Greenish yellow gas bubbles are released. Gas test, the gas produces bleaches the damp red litmus paper. Okay, maksudnya jadi hilang warna merah tu. Okay, what are the inferences? Chlorine gas is produced. Chlorine gas dia adalah mengakis. Okay, acidic, very acidic, so dia mengakis. Okay, cathode. Colorless gas release give a pop sound with a burning splinter. So what are the gas tests? The gas produces a pop sound with a burning wooden splinter. So our inference, hydrogen gas is released. Okay, what happens if we use 0.01 mole acid hydrochloric? Okay, at the anode, colorless gas release. Okay, rekindle glowing splinter kat sini answer for gas test. Okay, so inference oxygen gas is released. Okay, cathode colorless gas release. So what happen? Give a pop sound with a burning splinter. Jawapan dekat bawah ni semua dekat gas test. So inference hydrogen gas is released. Selain you tulis rekindle glowing splinter, boleh kata glowing splinter lights up. Okay, menyala. Okay, perbincangan. Discussion. Okay, which one of the concentration is higher? The answer 1.0 mole. Okay, name the product formed at anode for each electrolyte below. Okay, A, chlorine gas. B, oxygen gas. Okay, name the ions chosen to be discharged at the anode for 1 mole chloride ion. Okay, so 0.0001 mole hydroxide ion. So what are the conclusion? Our hypothesis accepted? Yes. So what are the conclusion? Ions with a higher concentration will be chosen to be discharged at anode. Okay, ni tugasan you on Monday kan? Okay. So kita hari ni kita sambung factors, the third factor that is types of electrode. Yeah. Boleh follow setakat ni? Can you follow? Atau
Boleh.
nak masuk? Boleh Kita masuk type of electrodes. Okay, kejap. Okay, type of electrode. Okay. Okay, ni sebab nanti you kena buat nota Macam biasa, habis je topik, you kena buat nota. Okay, simple note saja. Okay, type of electrodes. If the metal used as the anode is the same as the metal ion in the electrolyte, okay, maksudnya kalau you guna dia punya electrode, okay, kita ada electrode cathode and cathode and anode. Kalau cathode and anode tu you guna metal yang anode saja. Anode you guna metal yang sama dengan bahan dia punya electrolyte. Example, anode you use copper. Dalam electrolyte ada unsur copper also, like copper to sulfate macam tu Okay, at the anode, what happens? The metal atoms will ionize to form positive ions that dissolve into the electrolyte. At the cathode, the metal ions will discharge to form atoms of the metal, which are then deposited at the cathode. Okay, the concentration of metal ions in the electrolyte does not change, because the rate of metal ion atoms ionize to form metal ions at the anode is the same as the rate of metal ion discharged to form metal atoms, which are then deposited at the cathode. Okay, so maksudnya dekat sini, kalau you gunakan electrode yang sama dengan larutan, apa yang akan berlaku? Dia memang akan ada deposited. You akan tengok akan ada salah satu akan jadi lebih besar. Okay, that is the cathode akan jadi lebih besar because the metal akan lekat dekat dia. However, kepekatan, the concentration of the electrolyte does not change. You kalau you tengok, you buat berapa jam pun eksperimen tu, you akan dapati warna dia tak berubah. Warna electrolyte tak berubah. Dia tak makin pudar ke apa sebab dia punya ion tu akan diganti. Anode akan ganti dia macam tu. So dia tak akan ada kehilangan lah. Okay. Tak akan ada kehilangan ions. Okay. Number 2. Page 2. If the metal used as the anode is not the same. Kalau kita guna yang tak sama. Okay. If the metal used as the anode is not the same as the metal ion in the electrolyte, what will happen is the atoms of the anode do not dissolve in the electrolyte. So apa saja atom yang berada dekat anode tu tak akan masuk dalam electrolyte tu. Okay, negative ions in the electrolyte are discharged at the anode. Okay, at the cathode, the less electropositive ion will be selected to be discharged. Okay, so atom dalam anode tak akan masuk dalam electrolyte. Okay, so negative ions tu akan discharge. Okay, dekat anode. Manakala untuk cathode pula dia akan pilih yang mana electropositive ion lah yang akan keluar. Okay. So kita akan example tak bagi you faham. Example. Okay. Electrolysis of silver nitrate solution using silver electrode. Okay, tengok kita ada silver nitrate solution. And then we want to do electrolysis for that electrolyte. Silver nitrate solution tu kita nak buat electrolysis kat dia. And we use silver electrode. Okay, dekat dia punya anode. Okay, so what happens? Ion present in a silver nitrate solution during electrolysis are silver ion, nitrate ion, hydrogen ions and hydroxide ion. You nampak dia ada hydrogen and hydroxide because this is silver nitrate solution. Means you ada tambah dengan water. Kalau dia silver nitrate molten, dia akan jadi silver dengan nitrate only. Tapi bila solution, maksudnya kita ada add water. So dia akan ada hydrogen ions and hydroxide ions. Ada 4. Okay. So what happens at the cathode negative electrode? It will attract positive ions, namely silver ions and hydrogen ions. Akan pilih, dia akan tarik dua benda. However, silver ions are selected to be discharged because silver ion is less electropositive compared to the hydrogen ion. Tengok kedudukan dia, silver lagi bawah. Okay. So what happens? Silver is deposited at the cathode. So kita akan tengok dekat cathode ni jadi gemuk dengan silver. Jadi kalau you tengok dalam eksperimen dia akan jadi macam ada satu mendakan warna kelabu kan. Silver. Okay. At the anode, positive electrode, what will happen? Okay, it will form silver ions when silver atoms at the anode ionize. Okay. Nitrate ions and hydroxide ions are not discharged. So the silver electrode dissolves in the electrolyte. So apa silver yang ada dekat dia, dia akan keluarkan ganti yang ada dalam air tu. So dia akan masuk dalam electrolyte tu. Okay. So the concentration of silver ions in the electrolyte does not change. Because the rate of silver atoms ionized to form silver ions at the anode is the same as the rate of silver ion discharge to form silver atoms which are deposited at the cathode. So dari larutan tu ada unsur silver. So unsur silver dalam larutan pergi dekat cathode. Dekat anode pula dia akan bebaskan silver dia. So dia masuk balik dalam larutan. So concentration tak berubah sebab diganti keluar masuk macam dia berganti Okay, this is how lah kalau you tengok dia punya diagram macam ni lah situasi dia. Okay, dia akan keluar masuk dia ganti. Okay, silver daripada anode akan masuk dalam sini, silver daripada dalam sini, daripada air, daripada electrolyte akan masuk dekat, akan melekat dekat cathode. Okay, like that. Okay, next. What happen if we use carbon electrode? Maksudnya kita guna electrode karbon. Tak samalah dengan kita punya electrolyte. Electrolyte kita tadi silver contoh Okay, what happens? Ions present in a silver nitrate solution sama juga. Silver ions, nitrate ions, hydrogen ions and hydroxide ions. So what happens at the cathode? It will attract positive ions, namely silver ions and hydrogen ions. Dua ni akan tertarik dekat dia. So silver ions are selected to be discharged because the silver ion is less electropositive compared to the hydrogen ion. So kita tengok silver is deposited at the cathode. Sama je situasi yang tadi, silver akan melekat dekat cathode. Okay, tengok yang penting dekat anode ni, tengok what happens at the anode. Okay, positive electrodes. So attracts negative ions, namely nitrate ions and hydroxide ions. Okay, hydroxide ions are selected to be discharged because the hydroxide ion is less electronegative compared to the nitrate ion. So oxygen gas will be produced at the anode. Okay, kat sini akan ada gas oksigen. So what happens to the concentration of the silver? Kat sini nampak tak? Tak ada silver yang keluar. Okay, dekat anode tu tak ada silver yang masuk dalam electrolyte. So what happens? The concentration of silver ions in the electrolyte will decreases because the silver ions from the electrolyte are discharged to become silver atoms and deposited at the cathode. So dalam air tu, silver dalam dia akan bergerak ke cathode. So dah yang anode tak ada bebas silver langsung. So apa yang berlaku? Kita akan tengok concentration dia kalau you check awal tinggi, by the end dia akan menurun, merosot. Okay? Understand? Okay, this is what happens. Ni gambar lah. Okay, so apa yang berlaku ni kalau kita guna carbon electrode, so what's happen? Yang dalam ni, in the electrolyte, the silver ions will deposited, dia akan melekat dekat cathode. Sini dia tak ada unsur silver, so dia tak boleh nak ganti yang kat dalam electrolyte. So kita punya kepekatan, the concentration akan turun lah sebab all the silvers have moved to the cathode. Okay. So here we have experiment 6.4. Okay, from your textbook. Okay, ni eksperimen je lah. It is study the effects of type of electrode to the selection of ions to be discharged at the electrode. Problem statement, how does the type of electrode affect the selection of ion to be discharged at the anode? So our hypothesis, if carbon electrodes are used during the electrolysis of copper to sulfate solution, then the hydroxide ion is selected to be discharged at the anode. Kalau hydroxide ion is selected to be discharged means nanti dia akan keluar dia mestilah oxygen lah, oxygen gas. Okay, number 2, if copper electrodes are used during the electrolysis of copper sulfate solution, then the copper ion is formed at the anode. So kita akan tengok akan ada copper ion dekat anode. Okay, tadi kalau kita guna carbon dekat anode akan keluar hydroxide, ada oxygen. Tapi kalau kita guna copper sebagai electrode, apa yang berlaku, dia akan keluar ion cuprum, ion copper juga. Okay, so variables, manipulated type of electrode which is carbon or copper, responding product of electrolysis at the anode, constant type of concentration of electrolyte. Okay, this is how we do the experiment. Kalau tengok eksperimen ni kita cuma letak tabung uji di anode. Kenapa? Sebab dekat anode saja yang akan release gas. Okay, at the cathode dia tak ada release gas. Okay, so this is how we set up the apparatus and then the procedures, you boleh baca lah. Okay. So kita tengok. So turn on the switch for 15 minutes and test any gas release using a glowing Rudens printer. Observe and record the result. Repeat steps 1 to 4 by replacing the carbon electrode with copper electrodes. Okay, so observation tengoklah what's happened kepada glowing Rudens printer at the carbon electrode. Ada tak keluar gas kalau carbon electrode? Ada kan, tadi carbon electrode mestilah keluar oksigen. So lights up. Copper electrode ada tak oksigen? Tak ada. Does not lights up. Macam tu Ada hypothesis accepted, sepatutnya accepted lah. So conclusion, you ulang balik tulis hypothesis tadi. Okay, yang dekat anode tadi akan keluar apa? Okay, if you use carbon electrode akan keluar oxygen gas kan. If you use copper, only ion cuprum. Okay, so question. Okay, name the ion present in the electrolyte during electrolysis. Because this is copper 2 sulfate solution, mean dia mesti ada air kan. So dia akan ada copper ion, hydrogen ion, sulfate ion and hydroxide ion. Can name the ion selected to be discharged of the ions produced at the anode for the following type of electrode. So for carbon, hydroxide ion. Means kita akan dapat, we will collect oxygen. At the copper electrode, copper 2 ion. So tak ada gas lah. We will not collect any gas there. Okay. Any question before we continue? Ada soalan? Kalau tak ada soalan, kita nak tengok application. Okay. What are the application of electrolysis in industries? Apa kegunaan? Okay, apa kegunaan electrolysis dalam industri? Kita tengok kompleksnya, apalah benda electrolysis ni macam-macam. Macam entah apa-apa you belajar kan. Kenapa lagi kena belajar benda ni? Actually electrolysis have many uses in our daily life. Okay, the first one is extraction of metals. This one you have learned in form 3. Okay, you pernah belajar dalam form 3 tau. Tak tahulah sama ada ingat atau tak. Tapi you semak balik, you punya science in form 3, actually you have learned about extraction of metals. And this extraction of metals actually uses electrolysis. Okay, you have studied the position of metals in the reactivity series of metal and method of metal extraction from their ores. Maksudnya masa you form 3 dah belajar dah. Kalium, natrium, kalsium, semua tu you dah hafal kan reactivity series. Okay, so metals like potassium, sodium, calcium, magnesium and aluminium are extracted from their molten ores or salts through electrolysis. Yang you dah belajar pasal position of metals in reactivity series. So logam-logam macam potassium, sodium, calcium, magnesium ni kalau you pergi korek tanah, you pergi lombong dia tak akan keluar macam potassium, takkan potassium. Dia takkan keluar dalam bentuk unsur pure metal. Dia akan bergabung dengan unsur lain. Okay, unsur lain yang menjadikan dia macam batu tau. So that unsur kita panggil, kita akan panggil dalam bentuk ores lah, biji kan. So macam mana you nak dapat the pure one? So kita kena buat electrolysis. Okay. The second one is purification of metals. Ni macam extraction ni kita nak keluarkan dia daripada dia punya biji. Okay, dah keluar daripada biji. You nak bagi dia masih ada, dia tak tulen lagi. It is not pure. So to make the metals pure pun kita kena guna electrolysis, purification of metals. In the purification of metals, the impure metals is used as the anode, while the pure metal is used as the cathode. Later on teacher akan tunjuk macam mana dia punya situasi. Okay. During electrolysis, the metal at the anode will dissolve into the electrolyte to form ions. This ion will move to the cathode to be discharged and deposited at the cathode as pure metals. Okay, the third application is electroplating the metals. Ini yang selalu sangat kita tengoklah, penyaduran. You beli cincin yang bukan emas, dia sadur emas. Cincin yang sadur dengan silver, actually dia besi biasa je tapi dia sadur dengan silver. It is electroplated, it is plated. Dia plated dengan silver ke plated dengan titanium lah semua kan. So to make the plated, kita nak jadikan dia sadur tu, we have to use electrolysis. So kita panggil proses tu electroplating. Okay, in the process of electroplating a metal, gold, platinum, silver and so on. Okay, so we have to use electrolysis. Kenapa kita kena buat electroplating ni? Biasanya dia akan jadikan benda yang tak berharga, example macam besi buruk, bila you electroplate dia dengan emas terus jadi macam wah berharga. Okay, it makes the metal looks more attractive, and electroplating also makes that metals, contohnya scrap ke apa ke, withstand corrosion. Dia akan lebih tahan hakis, dia tak akan berkarat, lebih cantik, tahan lama. Okay, contoh kalau you pergi beli cincin yang sado dengan silver ke emas tu, dia tahan lama lah. Okay, nampak cantik kan. Okay, the fourth application is wastewater treatment using electrocoagulation. Electrocoagulation is an innovative technique to treat wastewater. Electrocoagulation applies to processes, namely electrolysis and coagulation. Ni macam mana cara dia orang nak rawat air kumbahan. Okay, najis kita buang-buang tu, and then dia akan masuk ke tangki kan. Tangki macam mana dia orang nak rawat najis tersebut untuk jadi nak keluarkan nanti jadi air yang bersih balik. Okay, that is electrocoagulation. Okay, so kita tengok the first one, ni extraction of metals. Okay, this is example, kita ada molten aluminium zinc higher density. Okay, this process consume electricity, memang kamu kena sambung kepada elektrik lah, dan kena elektrik yang agak tinggi ya. Okay, carbon dioxide form affect environment negatively. However, kita ada kesan buruk kat sini di mana dia akan bebaskan gas carbon dioxide. Okay, carbon dioxide ni kalau terlebih banyak dia akan menyebabkan global warming. Okay, red slug residue is toxic dan dia menghasilkan bahan dia punya apa? Sisa tu toxic. Okay, this is extraction of aluminium from molten aluminium oxide by electrolysis. Okay, ni dibuat dalam industri lah. Kita ada carbon anode, we have the steel layer, carbon cathode, mixture of molten aluminium and natrium. Okay, kat sini lah. Okay, so reaction involve apa yang berlaku bila you hidupkan elektrik. Okay, oxide ions donates electrons and undergoes the oxidation reaction and forms oxygen molecule. So dia akan keluarkan gas oksigen. Okay, at the cathode, aluminium ion is reduced to aluminium atom by receiving electrons and forms molten aluminium. So bila kita guna situasi ini, so what's happen, dia akan keluarkan gas oksigen, which is okay. And then dekat cathode tu kita akan dapat aluminium yang kita nak tu. Okay, this is the process of extraction aluminium from molten aluminium oxide. Okay. Second is to electroplate metals. Okay, ini yang you kena faham betul-betul sebab ini antara soalan yang selalulah ditanya dalam peperiksaan. Okay, for electroplating metals, object being electroplated at the cathode. Yang mana yang you nak sado. Example, if you want to plate the ring, you kena letak ring tu dekat cathode. Okay, kalau you nak sado sudu, you letak sudu dekat cathode. Apa-apa yang you nak sadokan. Maksudnya you nak dia asalnya buruk, jadi cantik. Okay, yang itu you letak dekat K, here, cathode. Sambung dekat terminal negatif. Okay, lepas tu, electroplating metal as anode. Apa bahan you nak sado dia? Contohnya you nak sado sudu ni dengan emas. So, the gold will be here. You kena letak gold dekat anode. Okay, positif terminal. Sebab we know positif akan pergi negatif kan. So, nanti gold ni akan bergerak pergi dekat kita punya sudu. So, nanti kita akan dapat gold spoon lah, sudu yang emas macam tu. So objek yang you nak sado akan berada dekat negatif. Apa yang you nak sadokan, you nak sado silver ke, you nak sado dengan gold ke, apa ke, mesti berada dekat positif. Another one yang you kena ingat, apa bahan, an aqueous solution containing the ions of the electrolyte. Nak guna electrolyte to make sure that this electroplating happens successively, you have to make sure that electrolyte tu ada unsur logam yang sama. Kalau you nak sado emas, means dalam electrolyte ni mesti ada unsur emas. You nak sado silver, dekat sini, dekat objek ni nak bagi dia jadi silver. So dalam electrolyte ni mesti ada unsur silver like that. Okay. So for example, to electroplate an iron ring with copper, The copper anode ionizes to become copper to ion. So kita guna copper to sulfate here. Kat sini kita letak copper, sini kita letak ring. Okay, copper to ions move to the cathode are discharged and deposited as a thin layer of copper on the iron ring. Okay, however, what happens? The blue cuprum solution does not change because the concentration of cuprum ion remains the same. The rate of ionization at cuprum at the anode is the same as the rate of discharge cuprum ion at the cathode, copper ion. Okay, so you akan tengok concentration dia tak berubah sebab apa? Kita ada copper kat sini. Copper dekat sini akan ganti copper yang dah bergerak pergi ke objek. Actually, although kita guna copper dekat sini, yang bergerak pergi ke objek actually copper inside the electrolyte itself. Copper electrolyte ni akan pergi dekat objek. Copper yang at the metals off ni, metal yang betul ni akan masuk ganti balik. So kita akan tengok dia punya warna, dia punya concentration of the copper to solution takkan berubah. Okay. Okay, next. Purification of metals. Okay, nak bagi metal tu dapat yang pure lah, yang tulen. Okay, pure metals will be used as the cathode. Okay, dekat cathode yang pendek ni kita akan letak yang pure metal punya. So in this case you letak tin, yang ipis je. Okay, the impure metal as the anode. Impure ni maksudnya copper campur dengan benda lain lah. Mungkin ada batu ke apa kan. Copper plus iron, copper plus silver ke apa kat sini. Impure lah, maksudnya dia bukannya tulen. Okay, aqueous solution also mesti ada the same unsur, the same metals. Okay, kalau kita kat sini copper, kita nak dapatkan pure copper, so dalam kita punya electrolyte mesti ada unsur copper also. Okay, impure copper anode ionizes to form copper to ions. So copper dissolves to become copper to ions and impurities accumulate below the impure copper anode. The anode becomes thinner. So apa yang berlaku bila kita switch on the current, kan, kita buka bagi current lalu. So atom copper daripada sini akan masuk jadi ion, dia akan jadi ion. Okay, so dia akan bergerak. So yang impure tu, yang tak tulen tu, benda-benda lain kan, akan terenak, akan jadi mendakan dekat bawah ni. Sebab dia tak boleh bergerak. Okay, so only copper yang kat sini akan masuk inside the electrolyte and then it move to the thin copper. So by the end, kita akan tengok thin copper will become thicker, akan jadi lebih tebal. Yang impure ni akan jadi semakin kecil. Okay, so solid copper is deposited at the pure copper cathode. Okay, and the copper and cathode becomes thicker. Sini akan tebal, sini akan jadi nipis. Dekat bawah ni you akan tengok akan ada habuk-habuk. Okay, maksudnya yang itu adalah impurities, benda-benda yang tak tulen. Okay, next. Okay, this is in electrolysis for electrocoagulation. Okay, ini untuk membersihkan kumbahan najis. Okay, at the anode, a metal electrode such as aluminium ionizes in the electrolyte to produce positively charged aluminium ions. At the cathode, hydrogens are selected to be discharged to form hydrogen gas. Hydrogen gas bubbles are released from the cathode and rise to the water surface. So kita akan keluarkan hydrogen gas bubble. Okay, so then ni first electrolysis. Okay, dekat kita punya aluminium sheet akan keluarkan ion aluminium. Okay, dekat kita punya karbon tu akan discharge dia. Sebab dalam ni kan kita ada guna kita punya wastewater. Dalam wastewater ni ada macam-macam kan. So dalam sini dia akan bebaskan hydrogen gas bubbles. Okay, so sekarang macam mana kita nak angkat, nak buang najis tu. Okay, coagulation occurs when aluminium ions, Al3+, hydroxide ions and pollutants dan juga benda-benda yang kotor in the wastewater combine to produce a coagulant known as floc. Dia akan bergabung, aluminium, hydroxide dengan pollutants akan bergabung to perform floc. Akan jadi satu macam gumpalan ni tu kan. Okay, floc trapped in hydrogen gas bubbles. Dia akan ditangkap masuk dalam hydrogen gas bubbles and then brought up to the water surface. Dia akan naik dekat atas permukaan air. Kemudian dia orang akan buang lah. Okay, the remaining flocks yang mana yang tak ditarik tu, dia akan turun ke bawah menjadi baja. Okay, accumulate at the base. So this is sedimented floc. Okay, so kita tengok this satu video untuk menunjukkan kepada you what are the uses of electrolysis in industries. Okay, so far any question? Ada soalan tak nak tanya kat teacher? Kelas?
Tak ada.
Ada soalan jangan tidur tau. Okay, kita tengok video sekejap. Kenapa video yang tak bergerak? Sekejap Okay.
Applications of electrolysis. Important applications of electrolysis are electroplating, purification of metals or electro-refining, extraction of metals or electrometallurgy. Click on each application to know more. Electroplating. Electroplating is an electrolytic process by which a thin and compact film of a non-reactive or superior metal is deposited on an article made of a more reactive or inferior metal. Let us now see how an aluminium spoon, which is inferior, is electroplated with nickel, a superior metal. Electroplating is based on electrolysis. The article that is to be electroplated, here the aluminium spoon, is made the cathode by connecting it to the negative terminal of the battery. A pure nickel rod is made the anode by connecting it to the positive terminal of the battery. A solution of nickel ammonium sulfate in water is used as the electrolyte. When a current is passed, the nickel atoms from the anode lose electrons and enter the electrolyte as nickel ions. The positively charged nickel ions are discharged at the cathode by accepting electrons and get deposited as a thin film of metallic nickel on the aluminium spoon. Thus the aluminium spoon is electroplated with nickel. Purpose of electroplating: protection against corrosion, decorative purpose. Purification of metals or electro-refining. Copper obtained by the reduction of its ore is impure and is called blister copper. By electrolysis, pure copper can be obtained from blister copper. An electrolytic cell is used for electro-refining. In an electrolytic cell, rods of blister copper are used as the anode. An acid solution of copper sulfate is used as the electrolyte. Thin sheets of pure copper are used as the cathodes. When electricity is passed through the cell, copper anode loses electrons to form copper ions. These copper ions go into the solution. Copper ions move towards the cathode and get deposited at the cathode. As copper ions are transferred from the anode to the anode gets smaller as the cathode gets bigger. The concentration of the copper sulfate solution remains unchanged. The pure copper sheet gets coated with an increasingly thick layer of pure copper. Extraction of metals or electrometallurgy. The external view of the electrolytic cell used for the reduction of pure alumina is shown here. The cell is called Hall's cell after the US chemist Charles Martin Hall, who invented the process. Hall's cell consists of a steel tank. The tank is lined with graphite, which acts as the cathode. Rods of graphite are suspended into the molten electrolyte, and they act as the anodes. The electrolyte is a mixture of molten cryolite and alumina. Electricity is passed through and electrolysis begins. At the cathode, the aluminium ions receive electrons to become atoms. At the anode, the oxide ions lose electrons to become oxygen molecules. Pure metallic aluminium is tapped from the outlet.
Okay, so formative practice 6.1. Okay, kita tengok latihan daripada your textbook. You kena jawab ni Draw and label the structures of an electrolytic cell. Kita tengok. Okay, this is the answer. Cepat-cepat screenshot, you kena jawab soalan ni. Tulis dalam buku. Okay, this is the structure of an electrolytic cell. Okay, describe the movement of ions to the electrodes during electrolysis. Okay, during electrolysis, positive ions move to the cathode. Negative ions move to the anode. Itu saja. Okay, give 4 examples of applications of electrolysis in industries: extraction of metals, purification of metals, electroplating of metals, and wastewater treatment using electrocoagulation. Okay, so hari ini kita dah cover subtopic 6.1. Okay, any question before we end our class? As usual, you tolong buat nota lah seperti biasa. Buat nota 6.1 and answer formative practice 6.1. Tadi dah bincang jawapan kan, kita dah tunjuk jawapan. So you just buat dia punya jawapan lah. Okay, latihan tu mesti tulis. Okay, so ada masalah tak nak buat projek sabun? Ada kawan you dah siap tak projek sabun? So tolong siapa yang buat hantar nanti dapatlah TP6. Ni siapa tulisan Cina ni, lupa dah nama. Who is here? Yang gambar Cina?
Tu Kai Xuan ah.
Saya. Nanti teacher tak tahu. Tukar nama rename balik nama you. Tulis nama sebenar. Okay, sebab teacher nak buat you punya kehadiran nanti. Okay, any question class before we end? So far boleh follow tak topik 6.1? Lin Diviang tak ada soalan, maksudnya faham lah tu. Make sure you complete your work. Orang yang sama saja hantar latihan. Yang lain bila nak hantar. Okay, kalau you tak hantar latihan pun, setiap kali teacher bincang jawapan, tolong semak. Okay, tanda dengan pen merah. Jangan tunggu buka sekolah. Lambat lagi kita nak masuk. Okay, semalam pun berita kata mungkin September baru kita masuk sekolah. So kalau you nak tunggu September baru you nak buat, kerja you akan jadi sangat banyak. Okay, and this chapter 6, especially tomorrow, tolong masuk kelas. Jangan tak masuk. Please remind, tell all your friends. Because tomorrow teacher akan bagi tahu your project based learning. Okay, yang itu adalah project based learning yang wajib. Okay, so kalau you buat memang you boleh dapat TP5, TP6 and it is easy. You boleh buat dekat rumah. You boleh buat dengan gembira, seronok, guna bahan-bahan dekat rumah saja. Okay, so esok masuk sebab teacher akan bagi explanation dan teacher akan tunjuk contoh. Okay, macam mana cara you nak buat project tu. So kalau you tak masuk, you rugi. Okay, so thank you class. By that, kita jumpa tomorrow lah. We'll see you again tomorrow. Bye-bye.